Hello and welcome to the wonderful world of building models to quantify risk. If you're watching this video, I'm assuming you have enrolled to attend commercial management. The purpose of this video is to introduce you to some of the concepts that you will be learning about in your upcoming course. Given the limited time we will have with you in class, we want to give you a first crack at some of these ideas now to help prepare you for the practical activity that we will be doing together when we meet. By way of background, my name is Nathan McLean, and I will be presenting on a few topics as part of your program. One of those topics is about how to create models that allow us to put a number against the unknowns we may face when making decisions. I also teach a course called Business Modeling as part of the MBA program at the AGSN. When I'm not teaching, I'm either building financial models, often for large infrastructure projects, or I'm auditing financial models, both of which I do as a partner in a boutique firm called ClayMatter. Okay, let's get into it. The basic idea that I want you to come to grips with is that the future is uncertain. So while we can make assumptions and attempt to forecast, the only thing we can really be sure of is that whatever our prediction is, it will not be 100% accurate. In light of this known inaccuracy, what we can do is make use of what are called random variables. Random variables allow us to reflect uncertainty by creating models that aren't driven by static assumptions, but instead by random numbers that can change dynamically. Now, the random numbers we will use won't be completely random in the sense that they are chaotic and follow no pattern. Rather, they will follow patterns that we will define. What these patterns will look like are essentially driven by the four things noted on this slide. What we will call a seed, which is a random number anywhere between 0 and 1. A minimum value that is possible. The mean value, which is just a fancy word for the average of all the possible values. And finally, the maximum value that is possible. You will notice that under each ingredient, I've noted some numbers in blue. These are the values that we will use for the examples that I'm going to work through with you in this video. Alright, let's take a look at some of the more common patterns that are typically used for random variables, and then we will actually have a go at generating them in Excel. The first pattern that we will focus on is called the normal distribution. The main things to highlight about the normal distribution are that it is symmetrical, and it resembles the shape of a bell. For this reason, often you will hear people refer to it as a bell curve. So, how do we use Excel to randomly generate numbers that will follow this pattern? As you will see from the formulas I've noted on the slide, we simply use a function called norm.inv, and we feed it a seed, a mean, and a standard deviation. You will notice that the standard deviation isn't one of the four ingredients that I just mentioned on the earlier slide, but that's okay. We can easily calculate the standard deviation by taking the difference between the maximum and the mean and dividing that difference by 3. Okay, now is probably a good time to dive into Excel and demonstrate what all this looks like. I encourage you to also open up Excel on your computer and follow along with what I'm doing. The beauty of this being a pre-course video is that you can pause and rewind as much as you need to ensure that you can keep up. I strongly encourage you to take the time to actually do what I do on screen, as this will definitely increase your chances of being able to follow along when we eventually do our exercise in class. Alright, before I get into any heavy duty number crunching, I'm going to go to my Excel settings and ensure calculations are set to manual. So to do this, I go to File, Options, Formulas, and I've already got calculations set to manual. However, most people would have them set to automatic. So what you want to do is select the radio button next to manual and then press OK. And why we want to do this will become clear a little later. Now, to generate the normal distribution, the first thing I'll do is rename the worksheet to be normal. And then I'll make room for the ingredients that I know I'm going to need, which will be the minimum value, the mean, the maximum value, and the standard deviation. Now I'll leave a little bit of room and come down to row 10 and just put some headings for the various calculations I'm going to do. So I'm going to have a simulation counter, a seed, and what I'll call samples. So we might give these headings a bold format, center a line, wrap the text so we can see them. And maybe I'll make the width of these three columns column width of 12. Now I'm going to go to view in the ribbon and untick grid lines to reduce a little bit of the noise. And if I select cell A11 and hit the freeze panes button and select freeze panes, I'm going to do that so that no matter how far down we scroll, we will always see what's up in this header section. Okay, so you may remember that the minimum we wanted to assume for our examples was 0, the mean was 50 million, and the maximum was 100 million. Now the standard deviation we can easily calculate as the difference between the maximum and the mean divided by 3. And what I'll do is I'll highlight these cells, go to the Home tab in the ribbon, and give them the comma style with no decimal places, and that helps us kind of visually see the scale of the numbers we're dealing with. Alright, the simulation counter, we know the first simulation will be simulation 1, and from there every other simulation will increment by 1. I might give those a center alignment. And then I'm just going to drag this formula down, and I want to drag it to 5,000 simulations, which may seem like a lot of simulations to you at first glance, but actually that's about the right amount of sims to do in order for us to see the pattern of the bell curve that we want to see, so that we know that we're actually generating a normal distribution. Now naturally there's many other much faster ways to drag a formula down 5,000 rows, but this one has the benefit of giving me the time to actually explain why we wanted to do that. So you would have noticed when I first dragged, the numbers didn't actually update, but with the press of the F9 key, all of those formulas will evaluate and we'll see that we're dealing with 5,000 simulations. If I press the up arrow, we're back to row 11, move over, and I want to generate our seed, which you may remember is our random number between 0 and 1. And I can do that in Excel using the rand formula. So I press equals, RAND, open bracket. I don't need to give it any parameters, so I close the bracket and I press enter. And you'll see that we have a fraction here between 0 and 1, and if I press F9 to refresh, you'll see I get different numbers but always between 0 and 1. And that's the beauty of setting our calculations to manual. It gives us the control over when these random numbers update, and it's whenever we press F9. So to replicate that 5,000 times, this time I can just hover my mouse over the bottom right hand corner, double click, and I know it would have dropped down 5,000 times. And again, pressing F9 lets me refresh those, and I always see I'm dealing with numbers between 0 and 1. Okay, now I have everything I need to generate my numbers between 0 and 100 million using the norm.inv function. So I'll go equals norm.inv, open bracket. Excel even tells us what we need to put into the function. In this case, the probability or the seed, the mean, which I will lock with the F4 key, and the standard deviation, which I will also lock with the F4 key, close the bracket, and there we have a number between 0 and 100 million. I'll give that the comma format with no decimal places, copy it down 5,000 times, and the F9 key kind of confirms we're getting numbers between 0 and 100 million. Now what we want to do is basically create a chart called a histogram that will help us visually confirm that these numbers are in fact following the normal distribution. So I'll highlight column D and give that maybe a width of 3 just as a spacer column. And then I know I'm going to have a histogram bucket low calculation, a histogram bucket high calculation, and then a counts calculation. And I'll also make these columns have a width of 12, reset the height. And the other thing I'll need to define is a bucket width. So where I refer to buckets, it's basically the categories of the histogram and defining how wide they'll be. Now in this case, dealing with numbers between 0 and 100 million, a bucket width of 1 million is probably appropriate. So 1, and I'll give that a comma style, no decimal places. Oh, just noticed a typo there. Now our first bucket will naturally start at 0 and it will end at the width of the buckets, which is what's in cell F8, and I'll lock that using the F4 key, press enter. My next bucket will naturally begin where the last bucket ended, and it will end whatever the width is, and I lock that and I press enter. I give all these the comma style, get rid of the decimal places, highlight, and I want to drag this down until I'm going to get to an upper bucket of 100 million. And if I calculate, I need to go a little bit further. And there we go. And I know I want to stop at 100 million because my maximum possible value is 100 million. Now all I need is a formula that will count how many of the numbers in column C fall within each of these buckets. And thankfully, I can do that using a nice function called countifs. Countifs will ask me for the range that I'm interested in this case what's in column C. So I'll select C11, Control Shift down arrow to highlight all of the calculations. I'll press the F4 key to lock them. And then what I want to do is, if I scroll back to the top, I want to ask, are any of those numbers, first of all, greater than or equal to, and I put those in inverted commas. I hit ampersand, and I hit cell E11. So I'm saying, are those numbers greater than or equal to the lower bucket? And I want to ask if those same numbers, so I can copy the range, Control C, and then Control V to paste, comma, are they less than, which I'll put in inverted commas, not less than or equal to, just less than, ampersand F11, the upper bucket. Close the bracket, and you'll notice I've only got an equal to once because I don't want to do any double counting. So I'll press tick. I'll see in the first instance none of my random numbers fall within this bucket, but if I press F9, we see that depending on what the random numbers are, different counts will come into each bucket. So again, if I copy that down, do my refreshing, now what I can do is insert a bar chart. Maybe I'll highlight the title and delete it, it's not that helpful. Move the chart out of the way. And we see we get that general bell shape with the symmetrical distribution. And even if I refresh and get, I'll click out of the chart, refresh to get different numbers randomly, they all generally follow that pattern of peaking in the middle and following a bell curve. So there we have it. We've successfully calculated a series of numbers that, whilst random, adhere to the normal distribution pattern. Okay, let's come back to our presentation. And now that we've generated our first distribution, the normal distribution, let's take a look at the next distribution we would like to create, which is called the triangular distribution. The triangular distribution is similar to the normal in that it is symmetrical, yet it isn't a bell curve per se, but follows more of a rigid triangular shape. Before we dive back into Excel, it's worth highlighting that the triangular distribution need not be symmetrical, but can be skewed in either direction. And it's for this reason that it is quite a versatile and powerful distribution. So here we see what it would look like if the mean was 30 rather than 50, or if it was 80 rather than 50. And so whilst it's always that general triangle, where it peaks need not be in the middle. Okay, no doubt you are now inspired to get cracking on simulating this. So let's go back to our Excel file that we've been working on. And let's have a go at generating the triangular distribution. Now, rather than start from scratch, I'm going to come to my normal tab, and I'm going to hold down the control key and drag with the left click and then let go of the mouse. And what Excel has done there is created an exact copy of the normal worksheet. And that means we don't have to start from scratch in generating our triangular distribution. So I'll double click that tab and give it a name of triangular. And I know that the ingredients for the triangular distribution, they won't need that standard deviation that we talked about before, so I'll clear that. And I also know that I'm going to want to do a few intermediate calculations before I generate my sample. So I'll highlight 2 columns and I'll press Control Shift equals key or Control plus, and that will insert 2 new columns for me. I'm going to call those columns left hand side LHS and right hand side RHS. And essentially, in theory, what we're going to do is we are going to randomly pick numbers that could be on the left hand side of the triangle, randomly pick numbers that could be on the right hand side of the triangle, and then our sample, instead of being the norm.inv function, will pick which of those 2 numbers we want to use based on our seed. So for now, I'll Control Shift down arrow to highlight the existing formulas, delete to clear them out, press F9, and we'll see our chart clears because right now we don't have anything to feed that chart. Okay, so I'm about to enter some formulas that may at first glance not make complete sense to you, because basically there are a bunch of formulas that have been derived using trigonometry, and trigonometry may just not have been your thing at high school, or maybe but a distant memory. But what we'll do is follow along with me, and I'll talk you through what's happening, and hopefully it will begin to make a bit of sense. So for the left hand side numbers, what we will do is we will start by pressing equals, and we'll begin at the minimum of our possible numbers, and we'll lock that with F4. And we want to add to that the square root of something. So we'll go SQRT, and what we want to take the square root of is our random seed, multiplied by, first of all, the difference between the maximum, which we lock with F4, minus the minimum, which we lock with F4, multiplied by the mean, which we lock with F4, minus the minimum, which we lock with F4. Close that bracket and then close the bracket for the square root, and we press tick. Now we'll give that a comma style, take away the decimal places, and copy that down 5,000 times. Press F9 just to make sure we're getting different numbers every time. Here we have a whole bunch of numbers that, in theory, fall on the left-hand side of our triangle. Now the right-hand side is a similar formula, but in a way the mirror image of what we just did. So, in this case, what we want to do is start with our maximum this time, which we lock with F4. This time we subtract the square root of something, and that something this time is 1 minus the seed, multiplied by the maximum value, which we lock, minus the minimum value, which we lock, close the bracket, times, open bracket, the maximum value which we lock minus the mean which we lock. And you may have noticed a little bit of a pattern there in that it's kind of starting from the other side of the triangle and working its way back. Again, don't worry if it doesn't make complete sense to you. The beauty of Excel is you can enter the formulas, see what's happening, and then try and reverse engineer what's going on. So I'll press tick there. Again, give it the comma style, take away the decimal places, double click to drop it all down, and F9 to refresh. And now we're getting our left hand side and right hand side numbers, so that all that's left to do is pick which one of those we want to feed into our distribution. Now to do that, we're going to use an if statement, because if we take left or right depends on the number of the seed. So we go if the seed is less than, and again we have some logic that's algebraically derived using trigonometry, but it's essentially the mean, which we lock, minus the minimum, which we lock, and we divide that by the maximum, which we lock, minus the minimum, which we lock. If our seed is less than that, we want to take the left hand side. Otherwise, let's take the right hand side. Close that, double click to bring it down, and now when I refresh we should see our chart update. And there we have what vaguely looks like a triangle, but for the randomness throughout. But if we keep refreshing, we consistently get our triangle peaking in the middle, without necessarily the bell shape, but nonetheless we have now successfully created both a normal distribution and a triangular distribution in Excel. Okay, coming back to our presentation. Okay, the last but by no means least distribution to simulate is what is called the PERT distribution. Once again, you'll notice the PERT is quite similar to the normal in that it's both symmetrical and bell-shaped. However, much like the triangular distribution, it can also be skewed in either direction. It could be, we could have a mean of 30, a mean of 80, and the PERT distribution will maintain its bell shape. So quite a powerful distribution to be able to create. Now you may notice that some of the formulas up on the slide look a bit scary at first, but hopefully by now you've realized that what may look like scary mathematics on paper can actually be fairly easy in Excel. Now, rather than me walk you through this one in detail, my challenge for you is to have a go at generating this one for yourself. So noted here on the slide are all the formulas that you will need, but you may notice that the function you will need to use is the beta.inv function, which takes a few more parameters than the norm.inv function, particularly the alpha and beta. But again, all the formulas you need are laid out here for you. And you'll notice that the core ingredients of the minimum, the mean and the maximum are really all you need to be able to work out these numbers. Now to give you a little help on how to get started, let's just jump back into Excel briefly. Now to get started on the PERT, I would recommend going to the normal worksheet, holding Control, left click to take a copy, and we'll rename that one PERT. We will clear out the samples because we know we're not using the norm function. And what you want to do, this space that we had left earlier, is because we know for the PERT we need room for what is called the mean. I'll just write mu. The standard deviation, I'll write sigma. And what are called the alpha and beta parameters. Now once you have done these intermediate calculations, you will then be able to use your beta.inv function in column C, and your chart should update to then follow the PERT distribution. So there you are with a pretty good head start. Let's come back to our presentation. Now if you are able to work through the calculations and create a chart with a shape that is generally consistent with what you see on these slides, you can be sure that you'll be ready to rock and roll when it comes to the practical exercise we will do together in class. Okay, that brings us to the end of this video. Good luck with your endeavours to generate the PERT distribution, and I look forward to meeting you all in class. If you do need to get in touch with me before we come together, feel free to connect with me on LinkedIn, and I'll be happy to answer any questions you may have. Thank you.